Welcome to part 2 of case study ex3, where we'll continue to walk through how to apply key operators in RxJava's observable class. In particular, in this part of the case study, we'll show how various advanced RxJava observable operators can be applied to create, reduce, multiply, and display big fraction objects asynchronously. In addition, we'll show how to use various advanced single operators as well. As usual, you can find the code we'll be walking through at the link at the bottom of this slide. We're now back in my IntelliJ IDE, getting ready to take a look at another part of case study ex3. Let's start by taking a look at the ex3 class itself, which as usual provides the main entry point into the program. There are 3 methods under test in this example. We've looked at test fraction multiplications and test fraction exceptions in part 1 of the video. This time, we're going to take a look at test fraction reduction multiplications, which will use an asynchronous observable stream and a pool of threads to perform big fraction reduction and multiplications. As always, after all 3 of these methods under test are registered with the async task barrier, we run all the tasks using the run tasks method, and then the main thread will do a blocking get, waiting for all the asynchronous processing to complete in the background. We're going to go over here and take a look at test fraction reduction multiplications, since that's our focus on this video. So first thing we do is we create a string buffer, as always, to store the results. And we start out by printing sorted results into that string buffer. And you'll see why we do that in a moment, because we have a very clever way of being able to sort and display the results that we'll show at the end. In this particular example, we're going to use the observable generate factory method operator. And we're going to pass into it a lambda expression that will generate a stream of random, unreduced big fractions. You can see how we do this. We're going to call the make big fraction factory method, which will create a large random big integer as the numerator, and then also create a much smaller denominator. And then we create a big fraction using the value of factory method, passing in the numerator and the denominator, and whether or not we're going to be reduced. In this particular use case, notice we pass in false for reduce. So we don't do a reduction when we create each big fraction. Each of these big fractions that are made will then be passed through to the rest of the observable stream by using the onNext method that's defined in the emit parameter, which is an emitter. So those things will then get passed down. Now, keep in mind that the processing that we're going to be doing here to emit this is going to be taking place in the calling thread. So we'll be emitting in the calling thread. And we're only going to take up to S max fraction number of these random large big fractions. So remember, take is a suppressing operator that will put a bound on the amount of events that are going to be emitted. Keep in mind that without putting take here, generate would just generate forever. Keep in mind also that generate uses a cold, synchronous, and stateless factory method here that it uses to generate the values. So after we are going to limit the number of random unreduced big fractions, we then call flat map, and we use the flat map concurrency idiom. Remember that flat map is this very powerful transforming operator. And what we're going to do here is we're going to say for each unreduced fraction that we got from generate, we're going to call a helper method called reduce and multiply fraction. So it's going to be past the unreduced fraction, and it's also going to be past the computation thread pool. So let's go ahead and take a look at reduce and multiply fraction. And this is a very interesting method that does a couple of cool things. So first thing it does is it uses observables from callable factory method operator to go ahead and reduce the unreduced big fraction. And it does it in the background by subscribing to the scheduler that's passed as a parameter, which in this case is the computation thread pool. And then once we've gotten the reduction done in a background thread, we then call flat map again. So this is sort of a nested use of flat map, where we're once again going to apply the RxJava flat map concurrency idiom. And we're going to take the reduced fraction, and then we're going to multiply it. And you'll see what this does in a moment. So multiply fraction is actually a helper method we talked about in part 1 of the video. And just for kicks, in this case, I use single rather than observable. And I say single.fromCallable, passing in the big fraction that's passed as a parameter. We subscribe that to run on the scheduler, which again is the computation thread pool. And then we have the map operator that's used to multiply each big fraction by S big reduced fraction. We've talked about that before. That's that large constant. And then we convert the single back to an observable. We don't have to do it this way. I just did it for fun to show you how you could do it. We could have just said observable from callable and not had to worry about doing the conversion at the end. So what comes back here will be an observable to a big fraction that's been reduced and multiplied, or actually the reduction took place here in the earlier reduce and multiply fraction from callable factory method operator. And then we go ahead and multiply it here using flat maps concurrency idiom once again. So we have lots of concurrency going on is the bottom line for this particular method. What comes back is an observable big fraction that has been reduced and multiplied. So we're going to end up here with a stream of these things, and whichever thread in the thread pool is the last one to do the last computation will then be used to run the collect operator. Remember, collect is a combining operator that's going to take the stream of big fractions and then collect it into a list. So we use the toList factory method, which is defined in the collectors utility class in Java. So this is actually part of basically Java 8, if you will. And we end up getting a collect into a list. So that what we have now is a single to a list of reduced and multiplied big fractions. So the final thing we're going to do here on the way out is we're going to call the single flat map complete operator. And what that does is that waits till all the other computations are done. And then it takes the list that was yielded from collect, and it calls a helper method called sort and print list. So let's go ahead and take a look at sort and print list. Sort and print list is also very clever and very cool. So what it's going to do is it's going to take the list that's passed in as a parameter, and it's going to sort that list in parallel by using quicksort and by using heap sort. So we have a quicksort algorithm and a heap sort algorithm, and we're going to do both of the sorting algorithms in parallel. And the way we're going to do that is we're going to use single from callable, which is the factory method operator, and then we're going to chain that together with subscribe on, which will end up running the computation in the computation thread pool, which is the one for CPU intensive processing. So both quicksort and heap sort will run in parallel. And then we're going to come down here and we're going to use the array operator defined on single, which is another one of these cool combining operators. And it's going to wait for quicksort's result to be finished or heap sort's result to be finished. And whichever one finishes first, array is going to select that result. And then it's going to go ahead and use flat map completable to call the print list helper method. And you recall from part one of the video, print list goes ahead and takes the list, converts it into a single, and then goes ahead and will use do on success on the single to display the contents of the list, which of course will be sorted now because we just got done sorting it. This method returns ignore element, which returns a completable to indicate things are done. That gets passed back as the return value from flat map completable, which will come back as the return value from sort and print list as a completable. And then if we back our way out of here, you can see that we use flat map completable here in this test fraction reduction multiplications method in order to return the completable, which is basically used as a synchronizer back with the async task barrier to indicate that all the asynchronous processing that was running in this test method has finished. So now that you've taken a look at that code, let's go ahead and run the tests again. We'll ignore the first two results because we looked at them in part one of the video for test fraction exceptions and test fraction multiplications, and just focus on test fraction reduction multiplications. And as you can see, it does indeed print the results in sorted order, demonstrating that whichever one of our two sort algorithms finished first produced correctly sorted output. And this will then print the results as mixed strings in sorted order. So this is a very cool set of examples that demonstrate how advanced features in both RxJava Observable and RxJava's single class can be used for various interesting concurrent and parallel processing in a reactive streams model.